Good morning, good afternoon, or good evening, 8th graders. This is Mr. Warrington, and this is our first lesson in Chapter 9 on minerals. So the name of this lesson is Introduction to Minerals. And we're going to attempt to do a few things in this chapter, which we'll get to here in just a moment. But let's start out here with this question: what are minerals? And when we think about minerals, there's probably a lot of things that we don't really think about. Good morning, good afternoon, and good evening, 8th graders. This is Mr. Warrington. This is our first lesson in Chapter 9, Minerals. And this first chapter is just an introduction to minerals. But before we get into the lesson, let's take a look at some things. The first question we're going to answer is, what are minerals? And as we begin to do that, let's just take a look at some examples of minerals. For example, this one right here is galena. And when you look at it, it probably looks very pretty, but actually it's mostly lead and sulfur. And galena is one of the major ores that we use for lead. In fact, there's a little town down in the very southeast corner of Kansas, just about as far south and east as you can go, called Galena. And back during the late 1800s, early 1900s, they mined a lot of the mineral galena out of that area. It was one of the largest lead-producing sites in the United States. So it has a little bit of history there for our state. Unfortunately, the mining really caused a lot of problems with the groundwater. And we'll talk about that a little bit more in the chapter when we talk about mining. This one right here is gypsum, and there's also a lot of gypsum here in Kansas. And gypsum is the major component of wallboard, or what we might call drywall. So if you just kind of look around the room that you're in, whether it's school or at home, most likely those walls are made out of something called drywall. And in northern Kansas, up near Marysville, there used to be, anyway, years ago, a factory there where they made drywall. And they mined a lot of the gypsum in that area, took it a short distance to the factory, and that's where they made the drywall. So basically they crushed this up, probably treated it with heat or something, made a slurry of gypsum and water, and then ran it in between a couple of sheets of thick paper, and that's how you get drywall. Okay, this one right here is what's called smoky quartz. And when you look at it, this is a very good example showing the crystals in the quartz. And quartz comes in all kinds of different colors. You have smoky quartz, clear quartz, milky quartz, rose quartz, etc., depending on the impurities that you might find inside each of those different examples. And sometimes it forms really, really nice crystals like this. Most of the time it doesn't, though. Okay, this one is azurite, and azurite actually is a main source of copper. And it's actually that copper that gives it that bluish and that greenish color. And this last one right here, this is a piece of quartz that had a bunch of native gold embedded in it. We think about gold, we think of it being a little bit more yellow, but actually it has kind of this orange orangish look to it. And what they did in this case was they took nitric acid and poured it carefully over the quartz until they wore away the quartz. They dissolved it with the nitric acid. Quartz doesn't dissolve in acid, or at least not in nitric acid anyway. And so then they took basically a rock with a bunch of gold in it that was worth, a fair amount of money, and then turned it into a piece of artwork, which is worth much more money the way it is than just the value of the gold. All right, so you're starting to probably figure out that minerals are important to us as humans. We talked about drywall. We talked about, the fact that gold, we didn't talk about it, but gold has a lot of monetary value. Azurite being used for copper, galena for lead. And so we use minerals for lots and lots of different things. And basically, minerals are so important to us that it would be impossible for us to imagine life without them. They're used to make almost everything around us that we use, except for living things or things that come from living things like food, oil, wood, those types of things. But even so, without minerals, plants and animals could not live either. And so we are so dependent on the minerals that God has given us. And that's one way that God demonstrates His goodness to us, is the fact that He has provided us with so many different types of minerals. Well, here's the 3 questions I want you to think about before we start our lesson. First of all, what is a mineral? Secondly, what are different ways minerals occur in nature? We'll be answering that today. And then, where did minerals come from? We'll actually talk more about that a little bit later in the chapter. But right now, what I want you to do is to take a moment and answer this question that's coming up. And basically, I just want you to tell me what you think a mineral is. All right, well, let's take a look at minerals, what they are. And here's a picture of a diamond that's been cut a certain way to give it that nice shape. The first thing about minerals is that they are naturally occurring. Now, when we say naturally occurring, we say that they occur in nature. Obviously, God made them, so we could say that they're supernaturally occurring. But in this case, when we say they're naturally occurring, we mean that they are not man-made. So if you have something that's been made of minerals that man has taken and then formed into something else, then that is not a mineral as such, even though it might have minerals in it. Okay, the next thing is that minerals are solid. Mercury is not a solid at room temperature, so it's usually not considered to be a mineral, although it can be combined with other things to make a solid, which are minerals. But if it's a gas, if it's a liquid, then it's not a mineral. Minerals are inorganic, which means that they've never been a part of living things. And sometimes you'll see coal listed as a mineral. But coal comes from partially decayed animal material that's been, had a lot of heat and pressure put on it. So technically, coal is not a mineral. Trees obviously would not be minerals because they are organic. Your bones are not minerals. Even though they might have minerals in them, they are not minerals because they are organic as well. Next, minerals have to have a definite chemical composition. In other words, you need to be able to write a chemical formula for a substance in order for it to be a mineral. Now, sand is naturally occurring. It's solid, it's not organic, but you can't write a chemical composition for sand because it's a mixture of many different types of minerals. Okay? So if you can't write a chemical formula for it, it is not a mineral. And lastly, they have a crystal structure due to the internal arrangement of their atoms. Sometimes you can see that crystal shape on the outside, like we saw that smoky quartz a few minutes ago, and if you want to back up and look at it again, you'll be able to see that. Sometimes, though, you won't be able to see the crystals, but that doesn't mean that crystal structure isn't there. It's just maybe at the atomic or microscopic level where you can't see it expressed outwardly. Okay, let's take a look at some general facts about minerals. The first one is that over 5,000 of them have been identified, and new ones are being discovered all the time. Now, obviously, you're not going to learn about all 5,000 of them. In fact, we're only going to learn about a few of them this year, but you can see that there's just a huge variety of them that God has provided for us to be used in everything from gemstones to drywall. Next is that less than a dozen minerals make up over 90% of the crust mass on Earth. And on your paper there, you'll see a picture, and I'll come to a slide here in a moment, and we'll take a little bit closer look at that. But if you take just the first 12, they make up just a bit over 90%. In other words, you have another 5,000 or so that make up less than 10% of the Earth's crust by mass, which is kind of crazy when you think about it. Now, some minerals were formed at creation. Many were probably formed during the events surrounding the flood, and you'll read a little bit more about that if you haven't already in your textbook. And we'll talk about that more a little bit later in the chapter. So when we take a look at this here, we can see that plagioclase feldspar is the most abundant. It makes up 39% of the Earth's crust. Alkali feldspar makes up 12%. If you take these two together, they make up 51%. Just over half of the Earth's crust is composed of feldspar. Then quartz is at 12%. It's the third most abundant. The pyroxenes, which is a group of several different minerals. The amphiboles, which are a group of minerals, micas, clays, other silicates, and then the non-silicates make up only about 8%. All of these are going to be what we call silicate minerals. So 92% of the Earth's crust is made of silicate minerals, and only about 8% is made of non-silicates. And that'll make a little bit more sense as we go a little bit deeper into the chapter. So that's kind of a preview of coming attractions. Let's talk about some different ways in which minerals occur in nature. First of all, they occur as compounds. And if you think back a couple of years maybe to 6th grade, or maybe more recently if you came from another school, you need to remember that a compound consists of two or more different elements that are combined chemically with each other. So a couple of examples of some minerals that would be compounds would be halite. Halite is made of sodium and chlorine atoms that have been chemically combined, so we get sodium chlorine. So in the formula here, we see this first mineral here, sodium, Na, and then the second mineral, chlorine. When they combine chemically, we get the compound sodium chloride, which in some cases occurs as the mineral halite. Another example is chalcopyrite, which is copper iron sulfide. So it actually has three different elements combined chemically to form this particular compound. We have the elements copper, Cu, iron, Fe, and then sulfur. And actually two sulfur atoms, one iron atom and one copper atom, are going to make up a chalcopyrite molecule. Another way that minerals can occur is as native minerals. And native minerals are composed of only one kind of element, or one element at a time. Some examples of some native minerals are gold, which has the chemical symbol Au. So we have only one chemical element here, and that is gold. If you remember, whenever you have a capital letter, you have a new element. And so we have an uppercase and a lowercase here, so those two together are the symbol for gold, which comes from the Latin word aurum, if you remember that from Latin. All right, another example, and I already have the picture of that over here. This is sulfur, which has the chemical symbol S. And so for these two, because they're composed of only one kind of element, only one kind of atom, if you took all the atoms that are in this, at least the atoms that are all chemically combined with each other, then you would get just one kind of atom, and that would be gold atoms. This one, all the atoms in this are sulfur atoms, nothing else in there. Okay, now the third way that they can occur, let me wait here because I have a question for you to answer. Okay, another way that minerals can occur is as mixtures. And if you remember, a mixture is made of two or more pure substances that are physically combined. Now, in compounds, you have different elements that are chemically combined, but in a mixture, you have two or more pure substances that are physically combined. So when we talked about sand a little while ago, sand is a physical combination of many different types of minerals, several different types of minerals. Chocolate chip cookie dough, my favorite mixture in the whole wide world, is a bunch of different things such as flour and milk and eggs and sugar and chocolate chips, of course, that are physically combined with each other. And of course, we know that chocolate chip cookie dough is best before it's baked and not after it's baked. Although don't try that at home because you could get sick because the eggs could give you salmonella. But that's another story. Now, an example here is granite, this rock right here. And as you look at this rock, you can see that you have some different types of minerals in it. All these pink ones are the same mineral. And then you have these lighter colored ones in here, and you have some darker ones, okay? And so you have minerals such as quartz, feldspar, amphibole, and biotite. Amphibole and biotite are the darker ones, feldspar is the pink one, and quartz is the clearer one on here. So, the thing to remember there, of course, is that what you have is a mixture of different minerals rather than having a pure mineral. Okay, let's do a quick checkup here. And you can see on your notes there that you need to answer this right here. Which of the following are minerals or mixtures of minerals and which are not? So what I want you to do in your notes, I want you to, next to each item, put an M, capital M, if you think that it's a mineral or mixture of minerals, and then put an X if you think that it's not a mineral or a mixture of minerals. Okay, so go ahead and pause this for a moment. Do that right now. Okay, well, in class tomorrow, or on Monday, I should say, depending on when you're listening to this, on Monday, we will talk about these and figure out which of these are minerals and which of these are not minerals. So, that's all for this lesson. All secure in Sector 7, and we will talk to you later. Bye-bye.